Okay, so today we're going to be looking at constructions. Um, so if there's anyone here who does classes such as technical graphics, a lot of this would be familiar to you already. So I'm just going to look at our prior knowledge, so what we should know coming into this section. So first of all, we should know how to use a compass, which is this instrument here. So we have our needle point here and our pencil for marking. We should remember how to measure an angle with a protractor. So this is this device here. So when using this, we place our center on the vertex of our angle. This baseline here will go on one of the arms of the angle as well. And then we can obviously read our degrees off here. We should remember how to name angles and also the different types of angles. So we have acute, obtuse, reflex, right angles. So some other key terms we'll be looking at is a bisector, which I'm going to explain in a second. A vertex, which I already talked about. So this is where two arms meet. So it's kind of like the origin of the angle. Our radius, our arc, equidistant. So all these terms should be familiar to you already. And if you don't know any of them, I best advise that you pause this video and go back and look at them. So today we're just going to look at construction 1, which is this one here. So by the end of the lesson, we should be able to construct the bisector of a given angle. So I'm going to discuss this word bisector a little further. So we're going to look at our word wall today and what we're going to add to it. So today we have the word bisect. So I'm going to ask you, what do you think bisect means? Okay, so to help you a little further, I'm going to say this orange is bisected in half. So now what do you think bisect means? So bisect means to divide a line, angle, or shape, so basically anything, into two exactly equal segments or parts. So I've cut this orange directly in half, so I have bisected this orange. Okay, so now we're going to look at our first construction, which is how to construct an angle bisector. So which means we want to have the angle using just a compass, which is this instrument here, and a straight edge, which will be our ruler. So we start off with an angle. So we have one arm here, and our vertex here. So we place the needle of the compass on the vertex. We bring our arm or our pencil approximately halfway out across the arm. So if this is, let's say, 4 inches, will come out approximately 2 inches. So what we do with this is we draw an arc cutting across both arms. So there should be an intersection with this arm and an intersection with this arm. Okay, so now what we're going to do is we're going to move our compass. So our needle point is going to move from our vertex out to our first intersection on one of the arms. So it's going to go exactly on this point. So we can reduce our radius, so the distance between our needle point and our pencil, slightly. And we're going to draw an arc across the middle of our angle. So similarly, we'll move our compass up here and place our needle point on the intersection of our arc with the other arm. So the most important part here is from moving from here to here, we keep the same distance between these two arms. So we keep the same radius. So this is the most important thing. We can't change our compass. We have to keep the same radius. So similarly, we draw another arc across the midway of our. So these two arcs will now intersect. So the arc we drew from here, the arc we drew from here, they'll be the same distance. So from here to here and from here to this arc will be the same distance because we use the same radius. So now we draw a point where the two intersect, and using our straight edge we can draw a line from our vertex all the way out through this point. This line will be our angle bisector. So now our angle should be divided into two equal segments. A good way to check this is if we take out a protractor now, we'll be able to measure this angle and this angle, and we should see this, they're the same. So I'm going a little further and explain this more. Okay, so step one, we draw our angle. So here we have 44 degrees. We label our angle as we always do, A, O, B, whatever letters you want. So step two, using our compass, starting from the vertex, we draw an arc DE. So we draw an arc across both arms, starting from our vertex O. Step three, so with D as a center, we come out a radius, so we can use the same radius as we originally have, and we draw an arc across the center of our angle. So this does not need to intersect the two arms. So step four, which is pretty similar, we use our needle point, we move from D to E, and keeping the exact same radius, we draw this line, this blue line here, across the middle of our angle. Once again, it does not need to intersect the arms. So step five, we mark the point where these two arcs intersect. So remember, from D to P would be the same distance as E to P because we've used the same radius. So step six is we get our straight line and we draw a line from O through our intersection point P. So now we have our angle bisector. So we have 17 degrees here, we have 17 degrees here. So now moving on, I want you to practice these two questions by yourself. So this one here, using the above instructions, so A, B, and C on both of these. If you have any issues, I recommend pausing the video and going back and rewatching steps 1 to 6, which we did just before. So pause this video now and give these questions a go. So now I want to give you one quick real life example of constructing the bisector of a given angle in the real world. So here we have a baseball field which is in a 90-degree shape. So here we have our two sides to the field. So here we obviously have our batter. Out here we're going to have our pitcher. So our pitcher has to be exactly halfway, or has to be equal distance from here to here as he is from here to here. So a good way of doing this is when they're drawing out the field or they're lining it, they will construct the bisector of the 90-degree angle so the pitcher is standing in exactly the right spot. So if you can think of any other real examples in the world of where we might construct the bisector of a given angle, let me know and I'll give you some extra credit. Thank you for listening today. Enjoy your weekend.